Assalamualaikum warahmatullahi wabarakatuh. My name is Diky Afamby. I am from Informatics Engineering at UIN Sunan Kalijaga, Yogyakarta. Here I will explain about the derivative in calculus, especially its related rates. Related rates? Apaan tuh bang? Oke, santai coy. I will explain it. Okay, first, what is related rates? The related rates problem involves two or more quantities that vary with time and equations that express a relation between them. Typically, the values of these quantities at some instant are given together with all their rates of change. The problem is usually to find the time rate of change. This is not given. Okay. Next, how to solve related rates problem. One of the common methods to solving this is with an implicit differentiation. For example, and this slide is, suppose that x and y are each function of time, such that x squared plus y squared equals a squared, and in this case a is a constant. Next, differentiate both sides of this equation with respect to time t. This produces the equation 2x dx over dt plus 2y dy over dt equals 0. If the values of x, y, and dx over dt at a certain instant t are known, then the last equation can be solved for the value of dy per dt at time t. That is not necessary to know the value of x and y as a function of t. In this, it is typical for a related rates problem to contain insufficient information to express x and y as function of t. Warning: the most common error to be avoided is the premature substitution of the given data. So first, differentiate this function first, and then substitute the data. Okay, next strategy for solving. The first strategy is make a drawing of the situation if possible. It makes easier you to illustrate it. And next, use ladder to represent the variable involved in the situation. You can use whatever you want, say it x or y. And then number 3, identify all rates of change given and those to be determined. Use the calculation to represent them, like dx over dt, dy over dt. And number 4, determine an equation that involves both the variable from step 2 and derivative of step 3. Next, number 5, differentiate the equation of step 4. In this case, we use implicit differentiation. Then number 6, substitute all known values in the differentiated equation. And the last step is use algebraic manipulation if necessary to solve the unknown rate of quantity. Next, to understand more clearly about related rates, we use example here. A ladder 10 feet long is resting against a wall. If the bottom of the ladder is sliding away from the wall at a rate of 1 foot per second, how fast is the top of the ladder moving down when the bottom of the ladder is 8 feet from the wall? Okay. To solve this case, first you can draw on the illustration here. This is the wall, this is the floor, and this is the ladder which is resting in the wall, 10 feet long. And in the wall, I signed it Y, the floor I signed it X. And the upper ladder which is sliding down the wall, this is the dy over dt, and the bottom of the letter which is slide away from the wall, this is the dx over dt, which is 1 feet per second. So okay, we know that dx over dt is 1 feet per second, so we have to find the value of dy over dt here when the x is 8 feet. Okay, from here, because of, you can see in this picture, the wall, the floor, and the ladder is like triangle. So because this is triangle, we can use Pythagoras equation. And this is the Pythagoras equation: x squared plus y squared equals 10 squared. And from this equation, we determine this equation. So we get 2x dx over dt plus 2y dy over dt equals 0. And from this equation, we move the 2x dx over dt and the 2y here to the right side, and we get dy over dt equals minus x per y dx over dt. And here we just know the value of the x and dx over dt. We don't know the value of y. So how we can find the value of y? To find the value of y, we can use Pythagoras too. From this same equation, x squared plus y squared equals 10 squared, we get the y equals root of 10 squared minus x squared. The x squared here is the x squared. And from this equation, we get the value of y is 6 feet. So the y here is 6 feet, the x 6 feet, and the ladder is 10 feet. Okay, we substitute all this value to this equation, and we get dy over dt equals minus 8 feet per 6 feet times 1 feet per second, and we get minus 4 per 3 feet per second. The minus sign here is just because the upper of the ladder is sliding down. Okay, if this value is positive, so the upper ladder is sliding to up. Okay, I hope you enjoy my explanation. I hope you understand what I say. And thank you for watching.
Don't forget
Assalamualaikum warahmatullahi
like,
wabarakatuh.
comment, and subscribe.